Alright, so this is the last video for week 3, part A. The last topic we're going to talk about is libraries and modules. So this is a bit of a shift away from loops. Let's go ahead and get into it. Alright, so what are libraries and modules? So a library is a collection of Python code for this class that has already been written by someone else, some other developer, or potentially Python developers. And this code, it's ready to be used in your own code. So it's basically code that you can use in your own code that's already been written. It's already available for you. A standard library is a library, so it's a collection of code that's already written, ready for you to use. That's part of the programming language by default. So this is downloaded automatically when you download Python. Now that said, there are third-party libraries, which are basically libraries that are not standard libraries. So these would be libraries that you would have to download separately. I'll talk briefly about them, but that won't be the focus. The focus in this class will be standard libraries. So then a module is the way you organize libraries. So again, libraries are collections of code, and then modules are basically the individual files that contain the code. So this is why when you run your code in Python, you click run and then run module. So module is really just another word for file when you're talking about Python. Now, I know Canvas also uses the word modules, which I know is going to be a little bit confusing, but the Canvas modules is something different than the Python modules. So modules in Python are files. Modules in Canvas are basically those sections, those weak sections. It's kind of similar though, right? It's like little pieces of bigger things. But this is a different modules that we're talking about. So modules in Python, those are files. So again, I mentioned standard library, already downloaded to your computer if you install Python. Alright, so for this class, we are only going to talk about modules that are in the Python standard library. Again, though, you can use other libraries if you're interested. So if you're interested in other third-party libraries to do powerful things in Python, you have to first download them to your computer. I'll just note a couple of popular ones that people use. One is called Beautiful Soup. So this one is often used for if you're doing any web scraping. Web scraping is the process of taking data that is stored on a website and bringing it into your own Python code. So if you're interested in doing any like website automatic reading and processing, Beautiful Soup might be a good library to look into. Pillow is another popular one. So Pillow is a graphics library that's very popular. NumPy is also very popular if you're interested in statistics or data science or anything like that. NumPy is a very powerful scientific math module. Alright. So we are going to talk about two modules this week. We'll first talk about the math module, and then part B, we'll talk about the turtle module. Later in the class, we will talk about a third module as well called random. But again, the focus for this week in terms of modules is going to be math and turtle. So let's go ahead and talk about math in this video. So again, this is a module that is in Python standard library. So the way you use the code that is written already in this math module, you have to import it into your own file before you use the code. We'll talk about the ways you can import it. There are 3 different ways you can do that. In all of these methods of importing other modules, it's writing one line of code, and it's going to be a line of code that you're going to put at the very top of your file. Well, not at the very top, at the top right after all your header comments, like with your name and email and all that stuff. But you do want to put it above any constants. So again, there's 3 ways you can import a module. So this is one way that you could import math. You just type the words import math, right? Makes sense? So what this does is it basically creates a link or a connection between the math.py module saved somewhere on the computer and your own file that you're writing in. Now, I am going to take a quick second here to say whenever you're writing code in Python, do not save your file as math.py, because there is another math.py file, which is this math module. So don't save in your files as math.py, because there's already a math.py. So again, this import statement, import math, just links the module to your file. And then if at any point you want to use code from that module, what I mean by that is if you want to use a function that is defined in that module, or a value, so like a variable that has a value that is assigned in this math file, you have to type math dot in front of each function call or value that is specific to this math file. So that's one method of importing math. Another way you can import modules is to do from name of the modules, in this case it's math, import, and then specific things that you want to import separated by commas. So, for example, if you want to use the function square root, that is a function that is in the math module, you could say from math import square root. Maybe you also want to use log, in which case you can do from math import square root, comma, log. So that will import the math functions or values that you list right here after import, separated by commas. And the cool thing about this approach is then you don't have to type math dot in front of using square root or log, which is kind of cool. The third method of importing a module is to do from name of the module import asterisk. So this asterisk basically means import everything. So it's similar to this, except here you have to list out all the specific things you're going to use for the module. Here, it's just going to import everything. So, like this previous example here, you do not have to type math dot in front of things that you use from the module. So let's talk a little bit about pros and cons of each one, and what it looks like actually using these math functions and values. Alright, so here are 3 different programs. Each one is doing the same code. They're all going to print the square root of 10, but they're all importing math differently. So this first one here, this one just does the straight up import math. So again, if you just do import math, you have to type the word math and then dot in front of any function call or any value that you use that is from the math module. So you'll see here in this print statement I had to do math dot square root 10. That is because we used this import statement. We just did import math. Let's talk about this second example here, top right. From math, import square root. So this is the one that's saying, hey, from that file math, import this specific function. So the cool thing about this way is now you can just do print square root 10. You do not have to type math dot square root 10, which is pretty cool. Same sort of idea with this bottom one, this third approach, from math import asterisk, from math import everything. Well, if you import everything, you don't have to type math dot in front of the square root as well. So again, these are the 3 different ways you can import math, and these imports, it's not just for math. You can do the same thing with any other module as well, but we're just using math as the example here. That said, the preferred method is going to be this second one. You might think it would be the third one because it's really easy, right? But the preferred method is actually the second one, because the third one, it imports everything. And if you're in a situation where half of a second, for example, makes a difference in the runtime of your program, importing everything might take a long time if there's a lot of stuff in the file that you're importing from. So if you're in a situation where it really does matter if you can shave off an extra half a second or 2 or whatever from your runtime when you're running your code, it's good to avoid from name a module, import everything, because that's just going to take a long time to load. So again, after you do an import, your file can access these built-in math functions and predefined math variables. So these are the predefined math values. So let's take some time to talk about what some of these math functions and variables are. Alright, so here are some values. So these are variables that are defined, so their assignment statements are in the math.py module. So these are predefined values that you might find useful in your code. So pi, for example, E, INF. INF is actually a pretty cool one. It's basically infinity, but you can do like math operations with it. It's pretty cool, actually. And then just down here, I included an example of how you could use pi in your code. This is assuming that you did import math, and then you could do print math.py, and then +2. So these are math values. These are values that you can do, normal numerical operations with, which is pretty cool. Alright, here's an example of some functions that are in the math module. So again, the previous slide, those were values. So like variables, these are functions. So these are actions that can be done. So this function called a square root, that's going to give you square root. exp, that's e to the x, e to the power of x, e to the power of whatever you put in the parentheses. You have log and log base b if you want that. So again, with any of these math module functions, depending on how you imported math, if you just did import math, then you need to do math dot in front of all the function calls. So this line of code down here, this is an example of displaying the square root of pi. Alright, here are some more functions. There's a lot. Degrees, radians, sine, cosine, tan, all this good stuff. I will say I'm not going to expect you on a test to know the result of sine pi over 2 or anything like that. Don't worry about that. I'm just giving you I'm giving you an example of some functions you can do if you want. Some more useful functions, so these are really good if you're doing any rounding. So math has a couple different rounding functions. There's trunc, which is just basically truncating the floating point value to an integer. It will get rid of all the decimal points, so basically rounds down. There's floor, so that gives the largest integer less than or equal to x. So that also rounds down, but you have to sort of pay attention to the difference with negative numbers with trunc and floor. Ceil is the opposite of floor, so that will give you the ceiling. So that gives you the smallest integer greater than or equal to x, so that basically rounds up. So these are good, ready-to-use functions for you. If you need to do any rounding in your code, just remember to use them. You have to import math before you use them. So here's an example of a program that uses some math values. So I recommend going ahead and pausing this video and typing out this code, running it, making sure it works. As a challenge, go ahead and change that import math to a different import statement and see how it runs that way. So go ahead and pause this video, come back when you're ready after you ran your code a couple times, and we'll go from there. Alright. So in terms of the math module functions, the majority of the functions that are in the math module will return a floating point value. So they're all numerical functions, right? They're all going to turn some sort of number. So most of them are going to return a floating point value. Exceptions include trunc, floor, or ceil. Those are the rounding ones. So those will actually give you an integer instead of a floating point value. That said, I do want to take this time to point out the Python docs. So the Python docs, you might have seen them before. The Python docs are basically literally everything you would want to know about Python ever. So this is the home page of Python documentation. So every single built-in function, every single built-in value, it's written here. This is documentation. This is basically the comments for everything that exists in Python that's written by the people who wrote Python code. So if you're ever curious, okay, I just gave you a very small subset of everything that the math module can do. If you want to know all the things the math module has, you can go ahead and look at the Python docs, and there's a link directly to this math Python doc on Canvas. You can go directly to here, and you can look at all the cool things, and there's a lot. Now obviously I'm not going to expect you to know all of these for this class, but you should know, for example, if you want to look up in the math module, hey, is there a floor function? Okay, yes, you can go into the math module and see, yes, there's floor, this is what it does. So you should practice a little bit going into the documentations and sort of reading what's here and being able to take it from the documentation and put it into your code. So I recommend at this point, if you go back to this example here, to go ahead and add another math function or value that we didn't talk about today from this Python doc, just to get some practice reading through this documentation and adding it to your own code.